Hey everyone, welcome to another TechStrong Learning event. I'm Alan Schimmel of TechStrong and thrilled to have you on here today with us. Um, for those of you who have sat in on our TechStrong Learning events, we have different flavors of them. We have sort of the talking head slides, we have roundtables, we have hands-on demos, other kinds of formats. This next format that we're going to be doing today is kind of unique. It's really a joint production with our sister company and friends over at Tech Field Day. For those of you not familiar with Tech Field Day, it's like a unique event that you don't see out, and if you haven't seen them before, you don't know. But in essence, it gives vendors the opportunity to present before a live audience of Tech Field Day delegates, which when it's done in person is about 10 to 12 people who then ask, and they're not just people they're dragging off the street, they're industry experts on subject matter. And they speak for all of us. When they ask the vendor presenter questions, they probe about what the solutions there, what are the problems, and they're phenomenal. If you ever want to see them, if you go to the Tech Field Day YouTube channel, you can check them out there. Steve Foskin and team has been doing them now for, I don't know, 14, 15, maybe more years. However, what we do here is we try to take the best of the Tech Field Day experience and convert it into a different audience, into a different format. And so it's a Tech Strong Learning Tech Field Day experience. So we have excerpts from the live Tech Field Day that was done, but we also have the presenters themselves, the people from, in this situation, Keysight, to expand on what was discussed at Tech Field Day. And then we have a few delegate members to continue the discussion. So it's a really unique kind of format. I'll be honest with you, it's one we're still tweaking with to try to make it what works best for you as the live audience out there. That being said, though, let me jump into what we're talking about today. Actually, before I do that, let me talk a little bit about Big Marker, our webinar platform. We use Big Marker because it's just in a browser. There's no plugins. There's no downloads. Really easy. For most of you in your browser, in the right-hand side of your browser panel is going to be the Big Marker communications panel. And again, for most of you, the biggest thing you're going to see there is in black letters the word chat. And there's no hidden meaning here. There's no surprises. Chat is chat. And as you can see, we've had people already log in here and say hello from wherever they are in the world. And I always like to make sure the chat's working, see people interacting. So if any of you would like to, please log in, give us a hello from where you are. I still get a kick out of the global nature of the internet. I'm based down here in South Florida, but Alistair, who I'll introduce to you in a bit, is all the way over in Oz in New Zealand. We've got people from all over. So please log in, tell us who you're from, where you're from. At the same time, though, that's not the only reason we use chat. The real reason for using chat is we want you to be part of this conversation. So as you see the presentation, as you hear the discussion, if you have questions, comments, whatever you want to contribute, use the chat to do so. The only thing is I encourage you to use the public chat. We don't really use private chat here. It's not appropriate. Now, if you have a question of the panel, however, and you'd like me to bring that right up to the panel, next to the word chat in your communication window is Q&A, and it's grayed out until you click on it. But if you click on Q&A, it gives you, it's similar to the chat interface, but it actually gives you a chance to question directly to the panel. We'll bring that right up to the panel and get their responses on it. So use chat or use Q&A to communicate with us. And really, the more communication we get from you in the audience, the better this is, the more fun we have, all of us collectively. And so I can't encourage you enough to do that. That being completed, let me move on to the subject and people involved in today's presentation. So as I mentioned, the title for today is Building for Scale, Benchmarking and Performance Tuning of AI Cluster Networks. And it's with our good friends at Keysight. We welcome them. Let me introduce you to our panel members for today. First off, we have Alex Bartok. Alex is the lead product manager in AI data center solutions for Keysight Technologies. Alex, welcome and thanks for joining with us.
Yeah, thanks. Happy to be here. Thank you.
Beyond your title, Alex, you want to introduce yourself to the audience?
Yeah, so I've been working with Keysight for quite a few years now in very different roles, coming on 10 years maybe, and lately doing product management, where we're taking a lot of stuff that I learn when we work with hyperscalers, how they want to validate whatever they're building. Like I'm on the data center side, and then I'm creating products out of it so that the vendors can test it before, a little bit before than the hyperscalers. And then it trickles down to like a lot of other companies who can benefit all these recent developments. So that's what, like my area of work is.
Okay, very good, Alex. Thank you. Next up, I want to introduce you to, and I hope I don't butcher this too badly, but I'll do my best. Amritam Putatunda?
Yes.
Good. Thank you, Amritam, for being kind. I'm sure I didn't do it exactly, but Amritam is the Senior Product Manager, Application and Security Solutions for Keysight Technologies. Amritam, introduce yourself beyond that, please.
Thank you, Alan. And you did pronounce my name phenomenally well, I can tell you that.
Thank you.
Yes, Amritam here. I have been with Keysight from 15 years, overall 20 years of testing experience, and have been product managing all of Keysight's flagship security and application products from last 10 years. So, application traffic and security is kind of my specialty. I'm very excited how this is coming up into the AI side of it as well, right? You can see my excitement because there is a new, everything in this world is getting new. So working very closely on this particular infrastructures and understanding some of the application scale and security needs that AI is bringing in. So product management, also is rethinking everything from the security vendors tools, from the testing tools and everything. So it's a very exciting time for us to be here and talking to you about this.
Excellent. Thank you and welcome. Next up, I'd like to introduce you to, I think this is his first time here on the Textron platform, Brad Gregory, and he's here on behalf of the delegates. Brad, if you wouldn't mind, Brad is the principal and founder of MCN Strategies, but Brad, expand on that.
Yeah, thanks, Alan. Yeah, principal and founder of MCN Strategies. I focus on multi-cloud networking. That was my initial focus. Spend most of my time on the enterprise side as a network architect, design engineer. Actually started up the stack and worked down. Most people started at the bottom and work up, but started working with load balancers and application delivery many years ago, and then got more into the data center networking, fabrics. In the last 8-10 years, I went on the vendor side and worked for a large carrier neutral facility as a solution architect initially, and then went into product management, working on fabrics, virtual networking. How do we, as a community, deliver networking just like we deliver compute and storage in the cloud? So still a ways to go, as anybody knows that's living in that space, but yeah, that's what I'm focused on. And then recently got into AI for networking. I think, there's a lot of parallels to cloud networking that we went through 8, 10, 12, 15 years ago. And I think we're going to be able to apply a lot of the same learnings that we did back then, just in a little bit different context. Especially when we get into inferencing and app delivery, training is a different animal. We're still developing that from the ground up. So I'm really excited to see what Keysight is doing to kind of expose some of that, and so people can feel comfortable when they have to build their own fabrics on the back end. So thanks for including me. Really something I'm interested in.
Thank you very much, Brad. Next up, again, from the delegate side of the house, I want to introduce you to Denise Donahue, who's a business architect, technical author. Denise, welcome, and if you wouldn't mind, tell people a little bit about yourself.
Hi, glad to be here too. I saw Keysight at the Tech Field Day, last Tech Field Day I was out at, and spent a lot of the time going, wow, you could do that? I started my career as an economist, transferred into IT stuff like the servers, and then had to cook those servers connected together and fell in love with networking. And so now I'm kind of, after many years, kind of coming full circle and doing a lot of overall need more coffee. Overall viewpoint of bringing in the economic side, the business side, the networking side, the why side to everything, which is a lot of fun. And Keysight is really an exciting company. I'm glad that you all are here to find out about them.
So just another romantic comedy, huh, Denise? Thank you for joining us. Appreciate it. Next up, and he's really kind of if I'm the masters of ceremonies, he's your host. Joining us from all the way on the other side of the world in New Zealand, and appreciate him getting up at this, or waking up, or staying up, or whatever the right term is. He's with the Tech Field Day team, Alistair Cook. Hey, Alistair, welcome.
Hey, Alan, it's a pleasure to be back here with you and the TechStrong team. As you know, Tech Field Day and TechStrong work together pretty closely. We have overlapping audiences and different ways of reaching those audiences with the things they like to hear. I'm the event lead for AI Infrastructure Field Day, and it was at AI Infrastructure Field Day that TechStrong, not TechStrong, hang on, it's Keysight. Keysight presented at AI Infrastructure Field Day, and for me it was not quite as surprising just how amazing the Keysight technology and methodologies are, because I'd seen them before. As Brad mentioned, network deployment for cloud was a big thing in the past, and I vividly recall the Keysight presentation around validating an entire cloud infrastructure, at least the networking components of the entire cloud infrastructure, when I was a delegate at one of their presentations. So it was still amazing, but less shocking to me that Keysight has instrumentation for validating massive networks for AI infrastructure.
Sure, excellent. Thank you, Alistair, and thank you for all you do here. See, we got other people logged in and telling us hello from all over the place, Brazil and Greece and Denver. And thank you all for joining. Again, if you came in a little later, use the chat window here where we're putting the hellos in to ask any questions. But that being said, Alistair, if you don't mind, would you kick off kind of setting the stage here, and maybe we move to our first video clips and some discussion.
Before I get into that, Alan, I believe you're going to get your first real experience of Tech Field Day next week. Are you going to be?
Yes. Well, I'm actually not going to, unfortunately, be there in person. I'm going to.
Oh, you're only getting half the experience then.
Yeah. No, I've been to a Tech Field Day though.
Oh, good.
Last year I was out in Santa Clara, and I was very excited. But Security Field Day is next week, and very excited to be participating in that one.
But of course, we're talking about AI Infrastructure Field Day, and especially Keysight. And Keysight is a pretty big organization. We only work with a relatively small part of it. I dabble in electronics and see all of the beautiful Keysight test instruments that are available to more influential people working in electronics, or better funded people. The part of Keysight we're looking at is really about network validation and simulation of those workloads across it. And why don't we head straight into that first video and think about, as we're building networking for AI and probably networking in general, how we tend to focus on testing the lower layers far more than we do in the top. So Jared, can you pop us into that front end testing, that first video, please? we'll take a look at a little more.
What we have seen over the 20 years is that most customers, most users put a lot of emphasis in testing the lower layers. These are the lights on and lights off. Everybody notices if the link is down. Everybody notices the ping failing, right? Everybody notices if the switch is not sending traffic, if the routing algorithms are not working there. So people spend enough time and justification. It makes sense, right? Because this is where the core of it is, right? You first take care of heart, and then you have your muscles. But when you move up the layer, unfortunately, that's when people start to take some shortcuts because they have already spent so much money ensuring these lower layers work, right? So this is where they're looking at free tools, some kind of whatever, optimized ways, making shortcuts, right? But the point is, I will give them the credit, they still try to do tests, at least at the transport layer. I mean, TCP, UDP is working fine. But many, many big companies, I'm going to not name them, otherwise this will be my last conference ever, would always try to treat their users as their beta testers. Any of you who has used any kinds of cloud initially would know. And this is where I would give a lot of kudos to Crusoe, who went ahead and said, I'm not going to let my users be my beta testers for my applications, for their experiences. I'm going to do proactively some of this testing by myself and ensure that whatever infrastructures I'm giving to the customers, whatever that infrastructure is rated for, it's actually doing that exact job, and it's not going down when it comes to TCP, UDP, and application layer traversal of data over this front-end infrastructure.
And I think that echoes quite a bit of what Brad was talking about of starting at the top layer of delivering your actual application, and then realizing there's underpinnings, and probably then circling back to caring very much about delivering the application. That was you on screen, wasn't it? And yeah, you
At least the younger version of me, I'm matured since then.
But I don't imagine your opinion has changed.
No, absolutely not. It's only solidified.
And so that need to test your application as you're going to deliver it, and the focus for Keysight is inside that data center, inside your network. Do you see people failing to commit to testing that? And your slides slightly tongue-in-cheek said that just let your users test.
So I think I will rephrase some of it. Now that I'm listening to myself, people test it, right? But the people, what I strongly believe is that people are still in that position where they say we don't know what we don't know. Meaning, I have any of the free tools available that would do some level of stateful traffic, right? And I think Brad will agree to that because he's also coming from that world. So once that stateful traffic is passing through, I know I have TCP level connectivity and some web level connectivity because I've done my curl. But then they stop, right? So they're not going after, okay, I have a 400 gig link, 400 Gbps link. I have this infrastructure. Can it actually deliver 400 Gbps of real application traffic? Because that's what is going to be sent through the wire. It's not going to be stateless, unidirectional UDP traffic, right? So that's where the missing piece is, that there is a little bit of apathy that, hey, since I have already verified the link can do and the switching infrastructure can do 400 Gbps, quote unquote, stateless traffic, it may also be able to do application traffic. But there is a whole bunch of new paradigms comes in when you are sending application. There is TSO-LRO, which would handle large packets. There is receive side scaling, which will distribute the packets across cores. So all this, intricacies of load balancing and things like that plays only when you are doing multiple thousands or millions of connections of distributed application traffic. You start seeing it, which unfortunately sometimes discovered too late in the production.
Well, I think most network people would go, oh, that's the server folks' problem. We've got you the link. What do you want?
Yeah.
Yes.
And that sits at the core of one of the challenges we have in infrastructure, which is that in the end, we need to do this cooperatively and view it as all of us are here purely to get this application in front of our users and
Right.
to bring the business forward from that. And I know, having been the server guys, naturally I'm going to point the finger at the network team, and that culture is very problematic for us.
100%, 100%. So this is where a word that scares everybody is latency. Okay, so when you start observing latencies, and latency is not a simplified single number, it changes over the day, over the period, how much traffic load, how many users are in the systems, and things like that, right? And those two-way latencies, when in a TCP you're sending a SYN, you're getting an ACK, and everything is an ACK traffic. So that latency, if it scales up, especially when you are literally moving petabytes of your data from remote locations to the AI data centers, every additional millisecond, it would be transpiring into hours of delay, and sometimes it will be days as well, right? So optimizing latency, and where is the choking point, like you said, right? The server guy is blaming the network guy. And there's another beast here, which is the security infrastructure, right? So sometimes the security policies are going to not intentionally and rightly introduce latencies as well. So yes, identifying the choking point and optimizing it without compromising security would be another play here.
I think one of the other key elements as we're thinking about this for AI is that we're seeing an increase in the AI to AI. So as we're seeing more both agentic but also more use of model context protocol, we're seeing more use cases where there's network transfer between the different elements that make up your AI application. You might have one LLM that's being used to validate the input from your user and sanitize the input, another one that's doing the work of your application, another one that is taking the result and then validating that it's safe to return that information. And that's a whole lot more of the east-west transactions. And of course, that's a chain. The longer it takes to get through that chain, the more you're affected by bottlenecks anywhere in the front end or even in the back end of this. There's going to be significant issues to your application. And these are the kinds of things that Keysight wants you to get in front of, not discover because your users are unhappy.
A quick question. In the AI context, do we have a lot of good data on what is a good application, and standard application delivery? We've got so much data through the years of, this latency matters, this latency doesn't matter. This might affect the user experience. This probably won't affect the user experience. Is all of the AI application delivery, across training, inferencing, and then front end load balancing to inferencing, do we have enough good data to know what's good and what's not good? A, and then B, the second question, if we do, does Keysight have a simple way to, instead of giving me a lot of data, just give me a big checkbox saying, yep, this is good, roll it out now.
So there've been some new terminology taking roots in this area, especially when it comes to serving AI through inference. And the key terms that you would hear is time to first token, and then the token throughput, right? So how many tokens per second can you go through, send to them and get back from the model. So what's interesting, it's a choice between the cost of serving the model and the quality, how fast you get responses. And there've been publications, I just been recently reading around that, how, for example, DeepSeek made very conscious, not the model, but the company that trained the DeepSeek and they serve it, they made a very conscious choice not to put too much compute resources into inference, because they want to allocate as much as possible of that for training. And as a result, their quality of experience of working directly with the backend they provide on the inference is the worst across all the other providers that can give you an API access to DeepSeek. There's much more companies that provide much better experience. And it's literally what's driving their decision is they're not looking to make money on serving DeepSeek. They are making, their goal is to train new and better models. And so that's why they make this decision to allocate more compute to training rather than to inference. And as a result, you get bad quality. In general, though, we do have user experience where you do it chatbot kind of interaction, right? That's obviously on the surface. But I think what I would be very interested to learn, and I know if Amritam knows data or not, what happens on the agent to agent? What's the change between what's good for a human versus what's good for agent talking to agent?
Yeah, so let me take Brad's first question again and expanding on the information, right? So I would segment these latency requirements into two buckets. One is on the training bucket. So when you are training, right? So at that time, your latency requirements are not as stringent, right? So you're looking at whatever the service providers have usually promised you, right? If you're getting that or somewhere within the 30% ballpark, you're good. For example, let's say you're fetching it from a particular region of AWS with using an S3 to your local systems, and you have a link that would generally operate at a 10 millisecond latency. And as long as you are maintaining that for your training purposes, you are good, right? If you are going like 20 times, 10 times there on that at the highest level of scale, you're obviously having some issues, right? So there is no standards, unfortunately, right now. But like I said, whenever somebody is bringing this data into the AI data centers, there are some latency SLAs that their service providers have committed to, and as long as you are meeting the ballpark, you should be good. The more interesting case is the token side that Alex mentioned, is that this is where the differential becomes a big thing, meaning you can ask the simplest query to the GPU, like, tell me the capital of this country, right? It's a very simple question. And the answer, so the token latency there would be certain thing. Then you can ask, hey, go and read everything about Mars and write me a philosophical poem about the human families that are now residing on Mars in 2036 or something. I don't know. I'm just saying this is a philosophical question that also has some MCP, or you have to go out and start reading some things, right? So this would have a significantly higher latency, but it also has a higher GPU cost. So what as a user you are trying to, or as an infrastructure builder of this kind of infrastructure, you are trying to see what is the differential latencies here and how you can optimize. So this is where, when you are doing an A2A call, agent to agent call, or an MCP call, the incremental latencies that are introduced for these kind of calls has to be accounted for. And believe me, there has to be a lot of security policies in those between these calls, right? Because you do not want somebody else's information to be leaked out. Similarly, you do not want to access accidentally somebody else's information. So there is strict ZTN and zero trust authentication policies are being placed between the AI system and the agent or the MCP servers that is trying to access this outside data. So all these are compounding the latencies in such situations. As a test tool, our idea is not to pass a judgment, right? So we do not say this is the latency and you're good. Our idea is to just showcase that this is what the additional latency that is being introduced and what is exactly acceptable for you and where exactly you should see that this is beyond acceptable.
Yeah, I think that's a great point. Alistair, I was a network guy, so I was always complaining about the server people. So, but it was always, it was always in the eye of the beholder, right? And we really wanted application people, not necessarily the server people. Somebody wrote an application. Somebody had to define what the functional requirement was. You got to X number of transactions or whatever the case may be. But we needed somebody to define. When we were saying the network gave you 100 gig of throughput, right? Okay, great. I moved bits across a wire to 100 gig, but does that really tell you anything about the user experience and the application delivery to the user? So we were always looking for what equates to good. what looks good, because we didn't get it from the top down, right? We had to kind of just assume, layer 1, 2, 3, the video showed. We just assumed we did all the testing we could do at layer 1, 2, 3, and we didn't drop any packets. So we assume everything upstream is good. I would love to see AI really be AI, and then we can interact with AI. Is this good? Is this application performing the way it should be, right?
So Brad, I want to frame back what Keysight does and is used for. Keysight's used to make sure that when you designed your network, that it would deliver what you'd designed from top to bottom.
Perfect.
Rather than during operation, are you currently delivering the application that you expect? So you typically wouldn't be using this in your production application. What you'd be using is you'd be using Keysight to make sure when it came production time, you were certain that your infrastructure would deliver what you needed. And then when you decided you wanted to make some optimization, you'd work on a non-production environment with Keysight, and you'd validate those changes before committing them out to production. So you're absolutely certain, again, if the network behaves the way I designed it, if this change is effective, I'm not going to have an impact when I hand this over to production. I'm not going to have a increase in the latency for some critical path.
So
I think this is
implied in your statement. Then the lower environment needs to look exactly like the upper environment, right?
The test environment needs to look like the production environment?
Yes.
I think that's one of the key things where Keysight says you don't have to fully replicate. So let's hit video number 3, please, Jared, and just take a look at one of the AI-specific capabilities from Keysight.
You can benchmark performance of the network infrastructure, figure out how you can fine-tune the performance for them to perform better, reproduce issues you see in production, and also plan for new designs, new topologies, new generations of those networks, and understand how they would behave at scale. We do all of that by emulating behavior of the real GPU server, so you don't have to buy those for your lab.
And that's looking at typically what we would refer to as the back-end network. So this is the network that is connecting the GPUs together and that they're using to coordinate data amongst them. This particular network in 100 gig is not going to help you here. You're going to be looking for 2, 4, and maybe 800 gig for the actual leads coming down on this. Validating that network is really important, particularly for making sure the throughput of your training is going to come through. And Alex, I think this is the mind-blowing. You can do this fully emulate a GPU without buying a GPU, or at least emulate its network behavior.
Yeah,
that's pretty cool. Thank you, Alistair. That answers a lot of questions. Yeah, thank you.
Mm-hmm. Yeah. With more density, with less power, and even being able to say, well, I want to behave as GPA A versus GPA B, right? So without
this would be if we're looking at maybe upgrading from the to the hopper from the Broadwell, and you want to look at, is my network still going to be adequate? Am I going to starve my new GPUs if I don't change my network? These can have huge cost implications.
Yeah. And by the way, I just want to say maybe like very important clarification here. The bottleneck is very often in between the GPU and the network, which is a NIC, right? And so GPU tells to the system what is it essentially supposed to do. That's where the actual code runs, right? But then the infrastructure starts from all the interconnect that goes out of the GPU, internally or externally, right? And that's what we are benchmarking here.
Yeah, and typically for a training job, that's what limits your throughput, is the ability to share the data amongst all the GPUs when they finish doing computation, and then sort of consolidate and then redistribute that data back out across that back-end network. That's what limits your throughput, definitely for training. And for large model inference, it can also be limiting because you might need to use multiple GPUs to load your model.
Yeah, they totally have to in a lot of cases, yes.
Yeah. I did also want to kick into practical use of this, because one of the guests, well, the guest that you had when you presented AI infrastructure fields, there was Crusoe, who are neo cloud and new AI cloud, and of course needed to build out their infrastructure for delivering AI applications. And so that was a company that Amritam mentioned in the very first video. And they then spent quite a lot of time optimizing networking. So, Jerry, could you also play us through video number 2 to give a little context of the sorts of things that a company might discover as they're using the Keysight tooling to validate their design?
We're getting close to the point where we can really start to talk about how we have went on this journey from initially optimizing our pipeline to implement multi-tenancy VPC networking to optimizing that further. So, I mean, you can go and use Open vSwitch, and it's purely a software switch, layer 2, very simple. You can accelerate that onto an eSwitch on the NIC, and you can do this all using a kernel pipeline where we have both a slow path and a fast path. We're going to talk about this. I'll show a slide next that'll really illustrate this. This slide shows you a journey that we went on in terms of like efficiently building our cloud platform on this front-end networking. So we found that as we used OVS kernel, the slow path can become a bottleneck at very, very high connection rates. Why does that matter? Because you're moving from a world where when we started, everything was based on training. There were no cool models that you could really use for inferencing. Now there are a lot. So the world is changing from just model training to actually serving these models through inferencing. So the workloads really are starting to change. So these are the results of like comparing the behavior of these two data path acceleration pipelines. So we have OVS Doka hardware offload and OVS kernel TC hardware offload. And you can see here like very similar performance in terms of throughput, right? This is exactly what you would expect because essentially you're offloading as much of the data path as possible onto the hardware. You know, you just look here on the right-hand side on the server core utilization, you know, we can measure the efficiency of the Doka kernel bypass mechanism relative to the OVS kernel TC hardware offload. You can see that we're using more cores in the OVS kernel mode, and we're super efficient on OVS Doka. But that's not the whole story, right? We really need to test what happens with stateful traffic. And this really can stress the system, whether it's NVIDIA's implementation or it's the kernel implementation with the OVS kernel module. But in this very simple thing, you can see that we're very close in performance still at about 25,000 connections per second. This is where we're actually leveraging both NAT and potentially access control list rules. But Doka achieves this performance, you know, initially this ramp up in connections per second much quicker. It takes OVS kernel a bit longer. If you're monitoring the performance of the underlying kernel, you're going to see like a lot of spin lock happening. There's a lot of work still being done on the kernel side with OVS Doka, and the kernel bypass is just a single CPU core that we reserve for this purpose. And that's what gives us a lot of determinism. You know, in this example here, we're actually testing with very small payloads. So we're able to really stress the interaction between the hardware and the driver.
Just a quick point on that. Since the connections per second terminology came up, if you think of applications, right, most applications will open a tremendous numbers of connections to serve their purposes. Nowadays, modern applications, right, they would continuously be chattier, small packets, small TCP connections, but it's a complete stream of connections continuously, right? So that's why this is something that's not always tested because, you know, people, like I said, layer 2, 3, forget layer 4, 7. So that's when you start looking at small packets, small transaction that happens in real life, you start seeing certain levels of problems that gets exposed, and as early in the life cycle that it can get exposed, the earlier it can be fixed. Yeah, so those types of like performance tuning is really important. Like
noticing the difference between these two lines. The blue line here is showing like a lot, a lot less determinism in the system at scale. This is really important to our customers. Our customers want some sort of like, deterministic band in which the performance of the system will remain. So for example, if we can say that, the system will remain under, 1 millisecond, that might be completely fine. They just don't want, a delta happening where you might be 1 millisecond and then spike into 15 or 30 based on the load that's on the system. Also, the fact that some of the systems are actually multi-tenant, so you don't want a noisy neighbor problem. You don't want somebody that's co-resident on the same machine causing an issue for you. You can see here again that at these sort of connection per second rate with the work that's going on in the kernel, that in the OVS kernel with TCA hardware offload, you're using a lot of cores because there's a lot of data path rules being programmed in the software data path and in the hardware data path. And this causes like a lot of like OVS's revalidation to happen, and you're using a lot of cores to maintain that. So around 28 less cores under this profile.
And I think really what Crusoe is doing in here is validating behavior at large scale, validating behavior for a complex environment, and validating that their changes are actually working correctly by having a consistent workload in there. Alex, I think that's one of the huge benefits of using the Keysight suite, which incidentally came from the original Ixia. If you occasionally see the Ixia brand turn up. That's absolutely crucial value in using the Keysight toolset.
Yeah, I'd say that what's important here is that, there is a layer in the data center that sits between the standard hardware and the drivers that you buy from a vendor, right? There is an application that is okay. It's something that customer brings in. But if you are a data center that is designed to rent your GPUs essentially, right? There's a layer of software in between that is your responsibility.
Guys, I'm sorry, we're getting some sort of bad audio clicking here. Jared, if you're on the back end, can you just mute? Well, it seems to have stopped. Alex, you want to talk again and see if it happened?
Yeah. Okay. Hope it works. No. Okay. So, and you see that's layer that is a system level software, right? That data center operator like Crusoe puts in between that hardware and the customer service. That will determine how well the customer can leverage the hardware that Crusoe provides to them, right? And that's what Amritam's product is designed to test in this particular case. That's where it was focused on the front-end network testing. Yeah.
I would fairly commonly see customers wanting to test all of the networks through, so also the storage network. Amritam pointed out that often we're ingesting data across that network. For those who haven't looked at typical AI infrastructure networking, you usually have 3 different networks. One, the front-end network where users are making requests in and we're sending commands in. There's another one which is just for delivering data, and that's really vital in the use case of training, where you're pouring in training data. And then, of course, the one I've talked about before is the one that joins together just the GPUs that are in the servers. Those 3 often physically isolated networks, definitely on physically separate hardware, are one of the big differences in AI infrastructure, and needing to be able to validate and test all 3 of those layers in order to make sure your application is running is kind of fundamental to being sure how your infrastructure is going to operate when your users start rolling up. Or in Crusoe's case, when your customers' users start rolling up.
I think that's an important point, Alistair. It is. Sometimes it's hard to justify the budget for doing management testing type of products, but as you're getting into doing AIs, where companies are having private AI with their own proprietary information, I think that's going to be critical for because it's going to become a critical tool internal to the company, and for many of them external to their customers. And if you can't verify that it's going to work properly, then you're going to lose productivity internal, and you're going to lose customers external.
Yeah, one of the things I've seen is some discussions of building your own AI infrastructure and your own solution versus buying from another vendor or buying a package solution. I think one of the elements where no matter which way you go, if you own the tin, you need to make sure it works correctly. So if you go and use maybe a cloud provider's AI platform, well, they will have been through this validation. I imagine Keysight is a provider to almost every cloud provider around. But if you're building this in your own data center, if you're building out your own training environment, your own AI environment, how certain are you that you're actually getting what was designed, that the design is fit for purpose, and that that's not going to hobble everything that you put on top of it? Because of course this is foundational layers. Those bottom layers are still vital to test, as well as testing the further up the layers.
Yeah, maybe one of the observations I want to share here is that, traditionally when the cloud providers would build, their network, and the question of performance was always the answer was always, yeah, we've got enough. Because the networks were always over-provisioned. Now, thing is, the AI flipped it on its head, and it's actually practically impossible to over-provision the network. There's always going to be a bottleneck in the network, any way you want to design it. So that actually puts some of the traditional cloud providers in the kind of a hot seat where the performance they demonstrate is not necessarily the best. And the other side of that is a lot of newcomers into this area, which we typically call neo-clouds. They actually make the point of demonstrating performance and periodically measuring performance as one of the core values they deliver to the user, and that's what differentiates them from others, because the user is really, they really need to know. And there's a whole set of tools that is already available, how to expose those numbers to the users from production. But for those numbers to be good, right, you better either buy the solution. Somebody gonna say, I stand behind the performance. That's one way, right? It's been very popular a few last years to do it that way. But then the other way is okay, what if I go, left or right? What if I need to have multi-vendor solution? My customers are asking for that. And what if I need to hire more people who can manage the infrastructure? And, there is much more pool of network engineers who've been doing traditional networking versus, HPC style networking. How can I hire those people? And maybe I need to build a different network differently in a more traditional way, and at the same time understand the performance as well. Performance would be, adequate. It's never going to be more than, you need. You just need to make sure it's not detrimental. And that's where we see a lot of this interest that's really made kind of data center validation, just a hot topic.
When do you think we'll start seeing Ultra Ethernet type solutions hitting the market for training?
Yeah, well, it's if you look at the Ultra Ethernet spec, what you'll find out is there are so many layers of what they put together as a coherent story, how you can make your system behave better. On practice, it touches multiple vendors. So there's a NIC side, there is a network side, there is a software side. And I believe what's going to happen is no matter if you actually truly going to have it all-to-all deployed at your data center, or maybe you're gonna just leverage certain pieces of it for the existing protocols. Like for example, you can have lower level performance improvements and still ride what is today is very common is a Rocky V2 traffic on top. So I think that's what we're gonna start seeing is people gonna be slowly adopting those features, and it's actually critical to know if those features bring you value, because they might be limiting your choice of which vendor you can buy from if you want to use those features, right? Since they're new, so you probably want to know if what they promise would actually be visible in your environments. Yeah. So it's hard to say if you're gonna see full adoption of the end-to-end UEC stack kicking in early enough, but time will tell. Yeah.
And standards move on. I wanted to highlight one of the elements of maturity for Keysight in this space, and it comes from our final video, Jared, looking at a fabric test methodology and highlighting that this is a published document of this methodology as well.
The methodology, high level, walks you through a lot of phases you gotta go as you build and as you design and build the fabric for AI to get to the point where it can perform great. The methodology itself is available for everyone for download. At the end of the slide deck, I'm going to have a QR code. Anyone can just download it and read it. So high level, how we approach that. First of all, when you design in a fabric, you have a lot of decisions to make, starting with what kind of topology you're going to use for your fabric. Like, for example, are you going to go with the traditional claw topology, or do you want to have rail optimized topology in your data center? Depending on the topology, you might have different choices about the algorithms you're going to use to move data around, so-called collective operation algorithms. You want to know how those perform depending on the amount of data you want to move. It's a big focus of the methodology itself, and how you slice the data into messages. Then you want to understand that if you have multiple workloads, they don't step on each other, right? They're not creating the noisy neighbor problem. And even within one workload, we actually have multiple communications happening in parallel, right? So it doesn't have to be a neighbor. It can be, you can be hurting yourself. So that's the performance isolation part. Now, load balancing is a super critical aspect of designing the network for AI. And we allow you to compare how different advancements in the load balancing could be compared to each other, right? So if you move from a typical 5-tuple SMP hashing to either using traffic engineering or building a load balancing that's QP aware, or using some other methods, right? So we describe you how to build a test bed, how to set up the test so that you can compare those. And then finally, but almost most important, is how to deal with congestion control, which first comes with question of how to build a lossless fabric. And lossless fabric is being achieved in Rocky V2 and Ethernet using PFC, priority-based flow control. And then on top of that, what are the other methods to control the rate at which the GPUs move data around can be applied, like ECN and DCQCN. And I'm going to actually show you how the DCQCN can be fine-tuned to get the best performance of it.
And if you'd like to see that fine-tuning, take a look on Tech Field Day's YouTube channel, and you can find the full presentations from AI Infrastructure Field Day 2 there as well. And there was a really good presentation that we didn't quite have time to bring in of tuning the entire DCQCN stack. And Alan, you're on mute. You wanted to join us.
Sorry, I was afraid I was the one making the noise. I had muted myself. On that note, though, again, I want to reemphasize, because people come and go during webinars, the entire presentation is available on the Tech Field Day YouTube channel, as well as on TechStrong TV and the TechStrong TV OTT app, which is available as an iOS app, a Google Play app, Android, Apple TV, Roku, and Amazon Fire. So you could actually watch along to the whole presentation, as well as the full delegate questioning and commentary. So, these webinars are meant to give you a taste to dive into certain aspects of the presentation. They're not meant to replace the Tech Field Day presentation. So please feel free to go look it up. And actually, Jared or maybe Alistair, if we have the URL for that on TechStrong TV or Tech Field Day YouTube, we could put it in the chat for people so that they can see it for themselves. But guys, we are coming up on the last 5 minutes. We did get a lot of questions from the audience today. I'm a little disappointed, to tell you the truth, but sometimes people just like to take it all in, and they're not here to ask questions. That's why we have professional delegates asking questions. So thank you to that. Keystone team, thank you so much. Right? I think you guys, Keysight. What is it? Keysight team, you guys did a great job here. Great job at the Tech Field Day as well. I want to thank you for that. Brad, I know you came in out of the bullpen last second. You did a great job there. You must have warmed up well. You got a good curveball, and thank you very much.
Thank you for the invite. I appreciate it. Good discussion.
Pleasure. And Denise, thank you, as always, for all you do as part of the Tech Field Day delegate team.
This is fun.
I think it is, but, there are people out there who have to work for a living. And Alistair, most of all, thank you to you. You do a great job, and I know you, as I said earlier, coming out of New Zealand today at all hours of the day and night. Thank you for all you do, not just here today, but always. Alistair has put the Keysight video URL in the chat room. I'd also ask, if you are a attendee today, take a moment, if you go into handouts, or Jared, if you want to put it out in the public chat. We have a 1-minute survey, what you like and don't like about these things, and we try to make them better as a result of that. So take a moment to do that. But I think that's going to wrap up today's presentation. Unless something else, Alistair, I'll give you the last word.
Well, thank you, Alan, and thank you both, Keysight, Alex and Amaton, and also delegates. Tech Field Day is made awesome by that combination of having our independent delegates and our awesome presenting companies. So do follow us on techfieldday.com, and do click on that survey that Jared has just dropped in the chat. Thank you very much, Alan, for having us here.
Always a pleasure. Good luck. And a reminder, next week, I think it's the 24th, Tech Field Day, Security Field Day, which I'm looking forward to. That's my cup of tea. And we'll speak to you all then. Until then, have a great day, everyone. We're out.
All right. Thank you.
Thank you.
Thank you.
Bye, everyone.